Okay, so basically the goal is to build your machine learning model and then assess its accuracy. Now, to do that, we're trying to make an argument that the data you get in the real world may be messy or not clean. So you may want to clean your data before you even start working with it. And before you can clean your data, you have to ingest your data into the platform. And I think this is not something new. You've seen this in Power BI and R, so it's not something new. Then you have to go ahead and clean your data and then handle all sorts of information. Moment. Okay. So I'm going to open the prompt. So you may want to use any of the tools available for this work. Okay, but I'm going to use lab. Okay, so I think the last time we did something related to this. So today I'm quickly going to take you through pandas. I think that is this folder. So let me create that file quickly. Oh no. So let me call this file data pre-processing. Okay. All right. So I also have this material here. So I have documents here and Python for data science and data pre-processing. Okay, I haven't sent this file to you yet. So I'll send it to your rep right after the class. Okay. So please, can you see what I'm displaying?
Yes.
Yes, we can see.
Sure. So as usual, we are going to do something about data pre-processing. And like I said earlier, with whatever company you are working with, any competition you join, most of the time, the data you get will not be in the format of which you want or the format which is ready to be used to build models. So what you have to do is to process the data before you even go ahead to build your models. Now, a classical example like this. If you have a data set with several columns in a table, and you have to build a model, I hope you know much about regression analysis by now, right? Hello.
No, Pasty, we haven't started with regression analysis yet.
Oh, you haven't started anything. Okay, all right. So regression analysis, what it tries to do is you have one variable called independent variable, and then we have another variable called dependent variable. But sometimes the independent variables can be more. It doesn't necessarily need to be one. So what happened is that we are saying that the dependent variable, the value in it, or the value it takes at any point in time, depends on the behavior of the independent variables. So for example, if you use students as an example, you come to realize that we can make this argument or case that any student who is performing well has been studying. Okay, all we are trying to say is the student performing well becomes the dependent variable. And so therefore, before a student can perform well, it is dependent on the student's ability to study. Okay? So that is what regression tries to do. But in most cases, you may find a lot of variables or independent variables that do not inform the dependent variables. So you may want to remove them, okay? You just have to select the columns of interest. And that also happens here in the data preprocessing stage, okay? So in this course, we are going to be using pandas as our tool for the data preprocessing. And in fact, pandas is an interesting tool. Going forward, we are going to see most of the things pandas is capable of doing. So yes, this is as a way of background, we are saying that real world data can be messy. It isn't all the time that the data is messy, but sometimes it can get messy. So it is up to us to clean the data to make it much understandable, or to put it in a format that is suitable for analysis. And basically, all you would want to do is to clean all of the data as much as you can to avoid any issues. Because when there are problems with the data, you are going to get funny results. Okay, just like the tradition in computing goes more like you put in trash, you are going to get trash back. Okay, so try as much as possible to clean the data. But of course, in this course, we are not going to dig deeper into how you can clean your data, but at least we are going to present the basic concept for you to understand some of the things you need to be doing when you want to clean your data. Okay. So yes, in data preprocessing, you are going to look at all of these things, more like data cleaning, okay, dimensionality reduction, feature engineering, and data transformation. We are going to see all of these things moving forward. Now, with some of them, we are not going to see them in today's lecture, but for that of the next session, we are going to see some of them. Of course, we are going to see a bit of the feature engineering today, but we will not understand the rationale behind doing that. And we are going to see that in our next session. And then dimensionality reduction, we're also going to see more over there. So the data cleaning is what we are going to see more of today's session. It's more about you removing unnecessary records in your data, okay, just to keep it clean. Dimensionality reduction has to do with sometimes your data size can be very big. We have several strategies for reducing the size of the data. Now, talking about the size being big, I'm not talking about maybe you have 1 billion records or something. No. So imagine this. Let me pull up Notepad. Let's do something. Oh, no, not this Notepad. Oh, not again. Okay. So let's pull up this Notepad right here. Okay. And say, I want you to give me your best guess. If I have numbers, ages of students, okay, in KNUST, and I say the first age is 20, the second is, say, another 20, the third is, say, 18, the next is, say, 19. If someone should ask you, what is the average age of a KNUST student, what would the result be? Can you quickly do that computation for me? Of course, that is going to be 20 plus 20 plus 18 plus 19. Then you divide everything by 4, right? And what is this giving us?
19.25.
19.25. Now, the message over here is that on the average, when you go to KNUST, students are around 19.25. Now, we haven't brought in the concept of standard deviation for us to know how dispersed the values are from the normal or the average, okay? So this thing here is supposed to give us a fair idea of the ages of students in KNUST. So of course, we can say that, okay, KNUST student, look at 20 years, 18, 19. So this one is a fair representation of ages of KNUST student, isn't it?
Yes.
Yeah, okay. Now I want to add one more. let's say that is 120. So we have this age, one person with the age 120. So can we compute that? So this is plus 120, and this is going to be divided by 5. What do we get?
It's 9.40.
Come again?
It's 9.40.
39.40. So are we trying to say that on the average, KNUST students find themselves within this age, like 39.40? No, you see, this is wrong. Okay, this doesn't give us a clear picture of the ages of KNUST students, and the reason is this guy. Okay, so the mean value is more like can easily be influenced by the existence of some big numbers. Okay, so this guy here, okay, we can treat this guy here as an outlier to say that, oh, probably we're entering 12 and that we entered 120, so we may decide to remove this one. Okay, now sometimes we wouldn't want to remove this, but we may want to normalize this data here or standardize it to say that, okay, I want to push each of these numbers here between 0 and 1. Do you understand? So you push this between 0 and 1, 0 and 1, 0 and 1. So whatever the case will be, this will also fall within 0 and 1. In that case, we have tried to push this value here to be equivalent in terms of strength with all of these ones. So this guy here being big doesn't even have any influence on the data itself. Okay? And we'll be doing more of this in this section called dimensionality reduction. Imagine another example. Imagine you have you want to check, I don't know which specific example I want to use, but you want to check something between KNUST and let's say UDS. So roughly, KNUST and UDS, which institution has got the highest population?
KNUST.
I think Tech has got a high population. So look at this. Imagine you pick some records from UDS to do some analysis. You pick similar records in KNUST, you do the analysis, and you come to realize that, oh, KNUST values are maybe up there as against that of UDS. Now you just wake up to make a conclusion that maybe KNUST is better in ABC or the kind of variables we were interested in than UDS. Whoa, for all you know, KNUST has got a very large number, and that's the reason why those things are coming in. So that large size or large number can influence the result. So it becomes relevant that we try to reduce the data to a certain point, bring them to the same level playground. Okay, so with that one, the result is going to be a true reflection of what is happening in UDS and what is happening in KNUST. And we'll be using this one here. In fact, if you don't know much about dimensionality reduction, your models you are going to produce are going to be, they won't be interesting. It's going to give you funny results. And I think you can see that in this one. Imagine you're training your model and you find out that KNUST student on the average are 39 years. You try to predict the next person who will come to KNUST, and the system tells you that, oh, the next person to come to KNUST may be around 38 years. But of course, the person coming is around 19, 20 years, thereabout. So because you trained your data on this thing, which is introducing this big variation in there, it is actually affecting your predictions and you'll be making the wrong decisions. So some of these things are important. Feature engineering, you would also want to select the features that predict something. Okay, that will be your interest. You wouldn't want to use all of the columns over there for your work. So a typical example is over here. I want majority of you to contribute. Can you tell me what drive increase sales or increase in sales? Assuming you're a company and you want to predict what drives your sales. What are some of the things that can drive your sale increase? I'm going to start by saying maybe advertisement. I think when you advertise, then you stand a chance of increasing your sales. Any other person? with any suggestion.
Discounts.
Come again.
Discounts.
Discount. Okay, so what I'm trying to do is that I want to look at sales increment. Okay, and I'm saying that sale increment is driven by advert. Someone is also saying that discount, right? Any other?
Promotions.
Promotion.
Yeah, so
Any other?
yeah, we can talk of increasing the distribution. That is increasing the number of outlets you sell to.
So outlets.
Yes.
Okay, good. Let's take this. Now, assuming you, all we are trying to say over here is, let me do A. Let me do this as, sorry, D. This as P. And then this one here as O. And then sale increment is SI. All we are trying to say is that in order to get a very high sale increment, or your sale increment is dependent, okay? This guy here is the dependent variable, and everything here is the independent variable. We're saying that your sale increment is dependent on your advert plus your what? Discount, isn't it? Plus your promotion, and then plus your outlet, isn't it?
Yes, sir.
Okay, good.
Yes, sir.
Now, what we are interested in is, we have some coefficient here. Let me call that C1. The coefficient C1 multiplied by A. Then we are saying that, okay, if we increase our advert by a certain coefficient C1, it is going to have some effect on this one, the sale increment. So D is also going to have an, let's say C2, okay? So we are going to multiply this by C2, we multiply this one here by C3, and we multiply this one here by C4, all right? In fact, I'm not trying to teach regression over here, but if I have to teach you regression, I'll take you into details to even add a constant, okay? I'll add a constant, but I'll explain to you what this constant here is. Now, what is happening is that we are saying that your sale increment value, okay, is as a result of, so let's say this year, our sale increased by 30%. Now we are saying that 30% was as a result of we increasing advert by 0.1, we increasing discount by 0.2, increasing promotion by 0.01, and then increasing our outlets by maybe 0.5. Okay, it means when we increase our advert by 0.1, 0.2, 0.01, and 0.5, we are going to result in sales increment of 30%. Now, if I put this here together, of course, it might not end up giving me this 30%. So it means that we have this guy here multiplied by a certain number. Do you see? A certain number we don't know. And that number is the C1 we are interested in. And this guy here also multiplied by a certain number gives us. So when we multiply this one here by those unknowns, and then we put them together, that should give us or contribute to the 30% increment in sales. But of course, there may be other factors that accounted for the 30% increment, but we don't know. Okay, and all of those things are embedded in the constant value. Okay, is that one clear?
Yes, sir.
Okay, good. Now imagine the data you were given. You had a column for sale increment. You had a column for advert, discount, promotion, this. And then you had another column. Let's say that column is called, let's say expenses. Okay. Now let's assume that, okay, let me put something like eating. Okay, eating. Do you think eating can actually affect our sale increment? Like you as a manager, you are sitting at home eating. Is it going to increase our sales?
No.
Of
No.
course, it's not going to increase it. But funny enough, when you were given the data, this guy was part of the columns. So if you include this guy here in your model by trying to hypothesize that, okay, if I have C5 multiplied by E, it is going to affect this one. Now, this guy here is going to affect your model drastically. And your performance for this particular model is going to reduce. It's going to be very poor. And that is where feature engineering comes in. It is up to you to identify or come out with certain techniques to know that, okay, this one here doesn't affect or doesn't have any relationship with this one. So I have to remove this guy here out of the model. But of course, it's part of the data. But when we are training our model, we'll not include it. Okay. I don't know if this one here makes sense.
Yes.
Yes, please.
Okay, that's fine. So in future episode, if we meet to discuss regression, I think I'll take you deeper to even discuss the concept of R and then R squared and standard errors and the likes. But let's focus on what we are here for. Okay, so that is what we'll be doing over here to identify the features that actually predict what we are interested in. And of course, we have some few data transformation in here to do. So, like I said, we are going to use pandas. Okay, this is the funny guy we are going to use. And yeah, we are going to introduce pandas and then see that pandas is just a library in Python. Okay, and then we use it to work on data sets. And using pandas, you can visualize your data. You can clean your data. You can explore your data. You can also manipulate your data with just pandas. Okay. So with respect to the data visualization, I will leave you, and I'll also provide links for you to look at how to use pandas for data visualization. We also have matplotlib for data visualization in Python, and as well we have the almighty Seaborn library for visualizing data. But assuming we have some time, I'll quickly take you through that. But if not, I'll provide you with links on how you can access those information. Okay, so this is it. I think you've seen this guy here before, right? This guy. We've all seen him before. You remember when we're doing the modules, I was trying to explain to you that we can do import something as this is the alias. So if you remember,
Yes.
I hope you
Yes.
went to practice, because if you didn't practice, then today's lesson is going to be like a nightmare, because we are actually, the reason why we're doing all of those Python programming thing is this one. We wanted to learn it because we're going to use it here. So if you couldn't revise that, I wouldn't know how you are going to come along. All right. So let's see something. I have the data on my desktop. Let me view all of these guys. Okay. So this is the data we are going to be exploring today. Okay. All right. So this is the data. And we have some EST here, which happens to be date. We have temperature. Okay. We have dew point. We have humidity, sea level, visibility, miles, something, wind speed. We have a whole lot of things. Okay. And this one here is more like this data, I think they try to use this one here to predict an event. So more like the weather forecast. You see, when you have maybe the temperature level, all of these things, they can now predict that it is going to rain or it won't rain, or it will be cloudy or ABC. So this is a sample data. So at the end of the day, we can decide to train this model here to predict. So at any point in time, you can go and pick temperature data, pick this data, humidity, all of these data, plug it into your model, and then your model should be able to predict that it's going to rain or it won't rain. Okay, so that is actually what's happening here. But if you look at this data here, we have a whole lot of issues in here. Look at this. These are supposed to be some values. They are missing. This one here also missing. Look at, we couldn't make any predictions for this one. We don't know the event that brought about all of this. So it seems, look at this. We also have T here for precipitation. Okay, they are supposed to be integers, but we have some T in here. So you can see that this data here is very messy. So we are going to look at how we can work around it. Okay. Of course, we are not going to focus on cleaning this entire data. That will be some task you have to take up upon yourself. Now, recently, I engaged in this one. Let me see if I can find it. I'm not used to going to Twitter. Let me see. I think I also posted it on LinkedIn also. So yes, guys, I'm also on LinkedIn. So you can try and then hit me up, okay, on LinkedIn. Let me see. I posted something. So in LinkedIn, where can I see all of my posts? I'm not. Where can I find them? I don't know.
Go to your profile.
Click on your profile.
Your profile. Click your
Where is it? This one?
Yeah.
Here.
Yeah, you can go there. Yeah.
Yeah.
Okay. All right.
Hold on.
Am I there?
Yeah,
I think I'm
scroll
there.
down. Yeah, scroll down a bit. Show all posts here.
Oh, okay. Good.
All right.
So, oh, not this, of course. Not this one, not this one. Oh, I didn't post it yet. Good. So this is it. I also engage in some data cleaning with the FIFA data sets, okay? And the data set had 18,000 rows with 77 columns. So let's try and then check against this. This one has got how many rows? Just 31 rows. And how many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is just 11 columns with 31 rows. But in this assignment, I cleaned 18,000 rows and then 77 columns, okay? Now I have the data, the analysis app here. So it is on GitHub. You can go and then clone it. So you can see all of the codes I wrote. If you are interested, you can pick it up to see what is actually happening here. Some of them may be at a very high level. You may not really understand what's happening, more like some of these things, but anyways, you can easily go through to check, this is a bit something, but I can easily go through to see how I managed to clean this data, all right? So this is more like some small motivation for you guys, all right? So if you look at this data here, we have a lot of issue in there, of which we have to try as much as possible to handle or to work around, okay? So we are going to work with this data. Let me do this. Now, what I want to prevent is to call a very long name, okay? So I'll rename this and then call it data. In addition, I'll move it into my project folder. So let me just rename this guy here and call it data like this. Now, after that, I'll grab it and then put it in my directory where I'm working currently. So, in fact, most of you would want to do this one. It helps a lot. So let me do data stack and let me also do 2024 pandas. This is where I am. So I'll drop my data here so that it is easily accessible. So if I come here, where is my, so you can see the data is here now, okay? So I can easily work with it. All right. So this is what we are going to do. We are going to import pandas and look at how we can use pandas for several operations. Okay. So the first thing we are going to do is to say import pandas. Okay. So this is what I'm going to do. I'm going to do import pandas as a PD so that any point in time I want to call pandas, I wouldn't have to say maybe pandas dot something. I can easily do PD dot something. Now, immediately I'm done with that, I may want to run it to see, yeah, everything here worked perfectly. So if I do, maybe I want to see the directory or all of the things in pandas. Now, these are kind of properties and then methods on pandas you can call. So you can see we have a lot of them. Okay, so we have something like directory is actually supposed to give me a list of the methods and the properties in a particular class. Okay, that is what I have here. So like I said, we can't do everything in Python, but as and when we are moving on, if something new comes up, I'll explain it to you. Okay, good. So it seems there is a guy here, Excel file. We have something like index. We have a lot of them. And then we have another guy over here called read something, read SPSS, read SQL, read data, read table, read, like we have a lot of them. We can even read a CSV file like that. So I can simply do pd dot read CSV like this, and I'll just have to pass all of the information that are of interest to this guy. But we are not there yet. So, all right. So this is what we just did. I hope, who is confused about this one? Who doesn't understand something here? Please, I'll need your response so that we can quickly move on.
We understand, Pasty.
Okay, fine. Okay, so the next thing I would want to show you is that in Python, we can use Python pandas for a whole lot of things. Okay, so we can decide to create series, we can decide to create data frames, a lot of them. But the difference between the series and data frame is that you can consider series to be a column of a table. Okay, so if I should launch this one here, this one, just this one alone, the EST is a series. This one alone is a series. But when I put these two guys here together, it becomes a data frame. So this table you are seeing over here is a data frame. I don't know if that is understandable. A column is a
Yes.
series, and then when we put columns together, we get a data frame. Okay. All right. So let's look at this. Just an example. If I have, let's say, my records like this, and I say that I have 1, 2, 3, 4, like this. Now, if I should print, if I want to get the data type of records, okay, and I run it like this, oh, if I run it like this, you can see this one here is a list. Okay, what about this? Imagine I try to say, hey, I want to convert this guy here to series, do you see? Now let me put records to this. Let me call this one new record. So, and I want to check the data type for new record to see what is happening. And you can see that this guy here is no more a list, but it is a pandas series. Does that make sense?
Yes.
Yes, sir.
Okay. So I'm going to call this data. Okay. Now, if I should call data, look at what is happening. It is giving me the values here, 1, 2, 3, and then 4. If I decide to say maybe June, and let me put Ama, and let me put Kofi, and the last person, of course, should be me. Okay, good. So if I should run this, you can see that we have all of these names over here. So you can see this is just a single column. Okay, all right. Now this column here by default are giving these labels, but of course you can decide to give them your own labels if you want. So instead of the 0, 1, 2, 3 something, you can decide to create your own labels. So sometimes we have one guy called index. Do you see this one? Index. So this one here is also very important. I hope you know how I pull this one up. Shift and tab should give you this. It says that the data is the records that I have over here, okay? And then we have index. Now, if you don't understand what index is, you can decide to read through this one here. It tells you what it is. Values must be blah, 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 blah. So the range, it can be anything at all you want, okay? And this is the data type, okay? So anything you want to do, try and then refer to this one if you don't understand something. So we can decide to give it an index to say that we want to change the default index that pandas gives us. But I wouldn't want to worry myself with this one. I have provided a reference over here that if you want to do that, you can do something like this, where you have these items. These are, okay, you don't know how it looks like, so you let me demonstrate that. So now let me say my records. Of course, you know what this thing here is, right? You remember we said this is a key value pair. So this becomes a dictionary, right? So let me say 1. 1 is supposed to be this. I can say 2. Okay, then 2 is going to have some value like 23. So I can now say my data is pandas.series, and I want to put my records through it. So if I call this one, you can see that I have been able to find my way out to change the default 0, 1, 2, 3 to some of these things. And of course, series is also similar to the list. So we can easily access the name AMA. So you remember how we used to access it, right? Do you remember this? How is it called? Do you remember when we had a list, say 12, and then we wanted to call the 12, we did L and then 0. Do you remember this?
Yes, Pastor.
Okay, good. The same thing can be applied to this one. If I try to access element 0, it is supposed to give me June, like that. All right. So we come to data frames, and with data frame, like I said, it is a bunch of series. Okay, so look at this. This is one series. This is also another series. Put together, we have a data frame. But you can see that we are calling the name data frame on this data, okay? But mind you, this one here doesn't become the label. These guys here become the column names. So I think I have it down here. So you can see what happens over here. This is the column name, another column name, and then we have this. But of course, you hardly do this, but I'll need to do this for you to understand that some of these things exist. So if I want to create particular records of humans, so let me put records here, and I say that I want to create humans. So, excuse me. Hello, doc. Yeah, me patch on my main from back right. Me work class kaka. Okay, sorry. So let's say I want to create a table, okay, and then give it a column with some values over here. Then I'll create the next column and then give it some values over here. Okay. Now, if I say that I want this to be name and then gender, now I can put name, maybe Pasty here, can put June here, and I can put, of course, Nanahima. Who knows Nanahima? Who knows Nanahima? Oh, thank you. Thank you very much. God bless you. God bless you. So let's say June is 24, and Nanahima, let me give Nanahima 25. Okay. All right.
Okay,
So
it's gender, not age.
oh, sorry. Okay, so let me put male here. Let me put female here, and then put another female here. Okay, thank you very much for the attention. So I can say that if I want to create a data frame out of this, I can call my pandas. Remember, if I didn't do this, I'll have to call the full name pandas. If I do this, I can call data frame on it and then pass my records to it. Okay, I now have my, if I want to know the type of data that I have at this point, you can see that I have a data frame, which is different from the first one, which was series. So let me try and then grab this one here, and you can see that I have name and gender. Okay, I have Pasty, male, and that. So you can add up to it as many as you want. Okay, you can do this. So you can see I've added a few descriptions over here to guide you when you're doing it on your own. Okay, so this is how we locate row values. Now look at this one. How do we locate this guy? 0. You know that we can locate the column, right? So of course, if I do data and then I pass name to it, of course, I'm getting the name column. In fact, if I should add double of this, that becomes even nicer. So you can see how everything is arranged. But what if I want to access this guy? I want this one and this one instead of getting this column. Of course, I can also add the column gender, and then I have the 2. But what if I want this guy? And that is the row selection. That is what this guy here is trying to talk about. Now, we usually use the location array. Okay, we can use the location, which is this one, LOC, to grab a particular row we are interested in. And it's as simple as doing this dot, the location, and which one are you interested in? I need the guy at location 0. And can anybody guess the result for this?
Pasty.
Okay, so someone is saying that we are going to get Pasty. Any other? You can see that we get
Pasty.
yeah, because all of these guys here are on the 0th row. Now, what if I want to grab this one and this one? How do I do it? These 2 guys. I hope you remember how to slice. You remember we did something like this?
Yeah.
You can do it here. Okay. Oh, I think this one here is accessing these 2 guys. I'm coming. I can put 0, 2 here. Oh, what did I do? Let me put, okay, yeah, sorry. I can put this guy here to also access this guy and then this guy. But I don't know what I did wrong, but it's supposed to be giving me something like, I was expecting this guy here to give me this. It looks like it's giving me everything, right? I don't know what I did wrong.
So 0, 1, 2.
From
So
0
give
to 2, so 0, 1, 2.
Okay, yeah. Yeah, I think it makes sense. So moving forward, we can also look at how to convert types. Do you remember in the previous session, we said that if you had a list of maybe items, or let's say if you had this 1, 2, 3, and then you check the type of L. Now this is actually a tuple, but we can convert this tuple here to a list. Do you remember that? Where we said we want to convert L here to a list and then get the type of L. And then we convert it to list. Now, the same way, we can also convert the a particular column to some data type. Okay, so this is an example. If I have this column here, A, which happens to be 1, 2, 3, what data type is this one? I think this is float, right?
That's a float.
This one here is a float. This column here is also a float. And if you want to convert it to an integer, this is how we can do it. We can call that guy. You remember this one, how I was trying to access the columns. So if I do data and then I do gender like this, I'm trying to grab the gender column. So that's what it's trying to do, dot as type. Okay, it is trying to ask me to push it to a different data type. So I have to type the data type over here. All right, okay. Try to autocomplete for me. So you, as you are typing, if you do this and you hit the tab, it will autocomplete for you. So I'm used to it. So I'll just start typing and then I'll hit the tab and then it completes for me. Sometimes it can delay, sometimes it can move very fast. Okay. All right. So that is what this one here is saying. If you use as type and then you can convert it to integer, you can use as type float, as type string str, and you can convert any single column at all of your interest. Okay. So if you have one column and the values over there are seen not to be integers, but they are supposed to be integers, you can use something like this here to convert it to an integer. All right. Now we are going to look at how to handle actual data. Okay, more like the data I give you. So this one here is some basic introduction to pandas and some of the things you can use pandas for. Of course, there are a whole lot of things you can use pandas for, but we are constrained. We can't have all of the time to do this one. So we are going to look at how to handle data. But before you can handle your data, the first thing you will do is to try and then pull your data in. Okay, you can pull the data into your platform. So this is how we do it. So let me try and then create this one and then call it rename handling data. Okay, of course we are going to import pandas. Okay, all right. So now that we are done importing pandas, the next thing I would want to do is to grab my data frame. Now, usually you can decide to call it data anyhow you want. But if you look at most examples, you're going to see something like DF. Now, let me prove that to you. Let me open ChatGPT and then ask ChatGPT to, oh, why is this thing here? I'm going to ask ChatGPT to write, please, can you see?
Yes, we can.
Yes, sir.
So I'm asking ChatGPT to write a pandas code to read CSV file named users. Okay, now let's look at what is going to happen. Do you see, I didn't ask ChatGPT to call it DF, but some way, somehow, I decided to use DF. And you know, ChatGPT was trained on a very large data set. Now, for most of the places you go, you will find them using DF. And then DF is the short for data frame. You remember I said that when you read a CSV file, the result is not a single column. We have multiple columns, okay? And that becomes a data frame. So we try to use something like DF over here for to represent the data frame. All right. So I'm going to use this to say pandas. Oh, it is PD, right? PD.read. So read CSV. I can do this and say that, okay, well, read CSV, what should I put there? Once you are not sure, you can hit Shift and Tab in there, and they can give you the signature to say that, hey, at the point of you trying to read a CSV file, you can pass all of these guys here to it. Of course, you wouldn't use most of them. This is what I'm going to use, the file. And the separator is, of course, comma. I wouldn't touch it because we are saying that it is a CSV, comma separated value. So I don't know why I should change the separator. Okay, there are a whole lot of things you may want to do. You can decide to force the data type to something else, but you can do a whole lot of things with it. Okay, so what I'm going to do is to read the file. Now, look at this. This is the file I'm working in. And in that same directory, my data is in. If my data was not in, I would say maybe I'm looking for the location, something up to where I can locate my data.csv file. But over here, the data set is sitting in the same directory as the file I'm working in. So if I do data.csv, this guy should be able to locate it for me. So let me call df, and you can see that we have, it is trying to give us a snapshot or a preview of the data. Okay. All right. So that is what we have over here. And this is the data we just loaded. Okay. All right. So we want to have a view of maybe just a few portions of our data. Sometimes the top 5, top 10, top 2, or the bottom 3 or something. We have these two guys here called the head and the tail. We can use these two guys here to get that kind of data. So you can see, I'm trying to give you a descriptive stuff here. In fact, these are codes I wrote them some years ago. Okay, I don't know, is it about 3 years ago or something? I chanced on it and I decided to use it for the slide. So when we are done, I'll try and see if I can get that for you. Let me see. I think it should be in data stack. Where is it? Let me see. I think pandas. Is it this one? No, it's not this one. Pandas. Okay, good. Should that be this? Okay. Yeah, I think it's the basic. So you can see these are some kind of codes I wrote some years ago. Okay. Look at this, about 3 years ago. I tried to run it. That's why you see 3 hours ago over here. That is when I was using it to prepare the slide. So it is also well documented. Okay. So I'll try and give you this material here. So you can use this comment here as something to guide what you need to do. Okay. It is this one. Okay. So you wouldn't want to display all of these things on your screen like this. Okay. You may want to see just maybe the top 3 of them or the top 2. So you can see that it reduces it to give you the top 3. Okay. This should at least give you some short insight with respect to the columns and then the data types in here. All right. Now you can also do the data frame, but then you need the tail. So you can pass maybe 3 to it, and you can see it gives you the bottom from the bottom. Okay. These are the last 3 values in there. Please, any question on this? Any question on this?
No, please.
Okay, that's fine. Now, we have a way of getting the shape of the data. Now, look at this one. How did I get to know that over here? How did I get to know that I had 18,000 these rows and then 77 columns? How did I get to know? Because I didn't actually have the time to read all of these funny things. Okay, so what I did was to say that, okay, I have a data frame and I want to see the shape of it. Now the shape is going to give me, this is the number of rows and then the number of columns. Okay, so if you should count this column here, you get 11. And the number of rows, you should get about 31 of them. Okay, all right. So the shape actually help us to get the number of rows and then the number of columns. But look at the result. What data type is this one? Is this a tuple or what? I don't know. So let me grab the type and then see. Of course, this is a tuple. So you remember tuple, we are not allowed to change some things about it, okay? But then if I want to get the rows, I can say that, okay, I have the shape here. Then if I need the row, I can say row is shape. Remember I said the first one is the row, and then the column happens to be the second one. Okay, I hope this one here makes sense. So if I do row, I can get 31. If I call the column, I can get 11. But of course, I can call shape and I'll get the rows and the columns. Okay. All right. Oh, did I duplicate this one? I think this one here is a duplicate. Let me remove one. I will remove this one instead. Okay. All right. Now there is a way to get the size. The size is just a product of this one here and this one here. And I didn't include the code. I just wrote it here for your reference. So if you want to get the size, it is as simple as getting data frame dot size. And this should tell you that we have 341 data points in this table. Okay. That is what we have here. All right. Now, you see this column here? All of these columns. There is a way to get all of them, okay? And then we can use the data frame dot column. Okay, this is supposed to give me all of the columns, okay? So you can see that at a glance. Sometimes you can have a lot of them. Now, imagine this data here. I have 77 columns. Imagine the display in the browser. This one, how do you think it's going to be displayed here? Some of them are going to be replaced with ellipses, like 3 dots, 1, 2, 3. Then it continues to the last one. So you might think you have just a few columns, but you have plenty of them. Okay, so if you do data frame.columns, this one here gives you a list of all of the columns in your table. Okay, so I have some few comments here to guide you. All right, so this is about selecting, okay, and we are going to do a whole bunch of things with the selection. Now, I'm going to start with this one. You already know how to select columns, right? Now, if I want to get a temperature column, I can simply do df like this and okay, temperature like this. Now, this one here gives me the column for temperature only. If I want the head for only the temperature, this gives me the first 5. I can ask it to give me only the first 4, and then it does this. So I want you to pay close attention to this. One way to select a column is by using the square bracket thing we are used to. Now, another way of, in fact, let me call the head on it so that I don't get a lot of them, just 3. Another way of getting the temperature is by doing df dot, you can type dot temperature, okay, and it shows up. So if I do this, it also gives me the temperature. So if I should call the head and then pass 3 to it, I get the exact same values as this one. Now, a word of caution. I'm used to this style. I'm not used to this particular style like that. Now, you can only use this style when the name, okay, doesn't contain space. Okay, imagine the root temperature space in space degrees. You can't use this approach to access it. It won't work. It will throw some errors because of the spaces. So in instances where you have some white spaces in the column names, you may want to reach out to this style or this approach of accessing the columns. Any questions on this one? Any questions on this one?
No, sir.
Okay. Now, I know how to access
No,
just
sir.
one column. Okay, I know how to access just one column. Can anybody help me access both temperature and then dew point? Anybody? You just say it, I'll type. I want to access these two guys. Oh, sorry, it is dew point and then temperature. Anybody with an idea? Okay.
I'm thinking that'll be temperature.
So what I want you to tell me what I should type.
Okay, so type df
Uh-huh.
Square brackets
Okay.
and then temperature.
I should
So
type.
temperature in quotes
Okay. Uh-huh.
and comma,
Uh-huh.
and then we add dew point.
Okay. Okay. Anybody with an objection?
Me.
Okay. Okay. So what is your suggestion?
I too, after DF, the square bracket,
Okay.
temperature in.
So someone is saying that I should add another square bracket here.
No. You separate them. It's like the temperature should be in a square bracket and in quotes.
Here.
Uh-huh.
Then do comma.
Uh-huh. Bring another square bracket, yeah.
Like this.
Comma.
Come again.
And we do it like this, uh-huh.
Okay, so someone is also saying we should do it like this. Any other person? Okay, we are going to test the two and then see that both of them are going to get themselves in trouble. So yeah, the first one blows up. Oh, good. Let's test the second one too. Oh, the second one, look at what happens. You see, there is an issue. We are not getting what we are interested in. Do you see? There is an issue. Okay, so let's try and then resolve this issue here together. Now, you remember that this one here, we are trying to extract a lot of things at the same time. So why don't we say columns? Now I put these columns here. Do you see this? These are the columns that I'm interested in. So df this, I'm interested in certain columns. Does this one here make sense? I know this one will work. Yes, but your style will not work. Now the reason why it will not work is that we are not assessing only one element. If you're assessing one element, we can just pass the element here and then assess it. But if you want to assess more than one element, now this is the assessing square bracket. Now the element you want to assess, if it is more, you have to put all of them in a list like this. That I want to assess all of this list. I want to assess this, I want to assess this. Does that make sense? Or is it confusing?
No, we understand.
Okay. So what you are trying to assess is not one thing. If it is just a single thing, you can just go ahead and pass it here. But you are not trying to assess one thing. You are assessing a list of items. Okay. And this is how we declare a list. You can grab everything in here and then put it in here. And I'm expecting this guy here to work fine. And in fact, we can even grab only the head on this one by saying dot head. That means we are selecting the head for temperature and then dew point. Any questions? Okay. So that is what we have here. If you want to assess only the temperature, you can do df.temperature and you are good. And this one here is the exact same thing as what we have here. But if you want to assess multiple columns, I decided to create a variable and then named it columns of interest. So in doing feature engineering, this is how you extract those columns. The columns you think can predict the dependent variable. Okay, you just pass them here like this, then you pass it here. Otherwise, you may want to write the entire thing in between these two square brackets. Okay, now sometimes you may also want to assess the values within a particular column. And of course, this is going to give us an array. It's not different from what we are seeing. But the most important thing you may want to do with respect to this one is the unique one. Okay, so let's look at something like this. If I grab df.temperature and I say I need the values, now look at what happens. It tries to give me an array of all of the values within that column. Now let's look at this one. If I do df.temperature.unique like this, it tries to give me the unique values in this column. Is it this? Yeah. It tries to give me the unique values in this column. Okay. So sometimes you count the values here, it might be less than this because this is giving you all of the values. This one is giving me the unique values in this one. Now, typically, let me show you something df.head. Now let's look at event. Okay, I want to grab event to say df.event. Look at this. Now this gives me a lot of things. I know that the event can be fog snow, it can be snow, it can be what and what, I don't know. So if you have data points like about 100,000, you see this one cannot display all 100,000. It will just display a few of them. So you can do event.unique like this to get all of the unique values in that column. So you see that there is a value called not a number. There's a value called rain. There's a value called fog snow, and then a value called snow. So in the column for event, these are the unique values in there. And moving forward, you come to realize that it will be necessary that you get the unique values. Now we also have conditional selections. Okay, you remember when we're doing the if statement and then the likes. So we are coming to apply them. Now over here, I'm going to ask a lot of questions. Now imagine df.head. Okay, good. See temperature. Imagine I want to grab all of the columns, given that the temperature is above 30 degrees. How do I do it? So what I'm going to do is I'm going to do df. Of course, you can do this and then grab the temperature. But like I said, I'm going to be using the temperature. Okay. I want to grab this one. Okay. Let me do okay. If I want to grab the temperature, how do I do it? Do you think I can do df dot temperature where this one here is greater than or equal to 30? Is this thing here valid? Let me do this. Now, look at what happens. I'm only trying to check for each row, is it greater than or equal to 30? So I just say df.temperature, is it greater than or equal to 30 for each of the rows? So it checked for first one, is this one greater than or equal to 30? It says yes. Is it? Yes, yes. But this one here is false. This is false. See, we have a lot of them that are bigger than 30 and a very few of them that are less than 30. So if this one here works fine, then we can use this guy here as a condition to grab df and then pass the condition to it to grab records where the temperature is above 30. And then look at it. All of the values we have here, you won't get anything that is less than 30 in this one. In fact, we can even decide to increase it by going, let's say 40. And you see it reduces further. So this is more like you are trying to filter the data based on certain conditions. Does this one here make sense?
Yes, sir.
Yes, please.
Yeah.
So I hope you know the reason why I didn't type temperature, because if you type temperature, it's going to blow up. It doesn't know what you mean by temperature. But I'm saying that this data frame, the column called temperature, is it bigger than or equal to 40? So that is actually what is happening here. But remember, we can also, yeah.
So what will happen if you don't, type df dot temperature, but you put temperature in quotations? What will happen?
If I put it in what?
Like you put it in parentheses, like you are calling that column. Yeah.
This one. If I do this.
No. Yeah.
Like this.
Yes.
This one.
Yes. Let's see what
this should work fine. I remember saying that this one is the same as df dot temperature. I remember saying that. So you can do this and it should work fine. Is it okay?
Yes.
Okay. So what you can do is you can simply say that if you don't want to get confused with this one, you can set your condition here and say that this is my condition. I want to check where the temperature is greater than or equal to 40. So you just do the data frame and you pass the condition to it and it's going to work fine. But you see, I'm calling data frame here because I'm interested in all of the columns. But if I'm interested in a specific column, I hope you remember how to do that. You have to specify all of the columns you are interested in. Then you add the condition to it. But because I'm interested in all of the columns, that is why I had to do it like this. So in this case, you realize that I have added an example here. So this is how we can grab multiple columns, and this is how we can attach conditions to it. So it is as simple as saying that, hey, let me move to the next. I'm saying that, hey, I need this data frame okay, with these columns. The column is, I'm interested in the EST. I'm also interested in humidity. And then I'm also interested in event. Okay, so I want to grab this column, and then this column. So this is it. It gives it to me, but I want to filter this one where the temperature is more than 40. So I'm now going to set my condition. So this is my where condition. I need another square bracket to say where the temperature is greater than or equal to 40, like this. Oh, sorry. Oh, what is wrong? Data frame has no...
the temperature spelling.
Was good. So you can see it filtered the data to say that at each point over here, the temperature was more than 40. In fact, it's not only temperature. You can even say event. If the event is the same as maybe rain. Oh, of course, we don't have rain. Let me see the unique values. Oh, we have rain. Oh, okay, it's event, not event. Okay, so I'm grabbing the event column. So all I want to see is, okay, let me put temperature here. I want the EST column, the temperature column, and then event column where it rained. So I want to see that whenever it rains, what is the temperature, and then what is the date for when that thing happened. And look at this. When the temperature was above 41, it was raining. Okay. So I'm going to do one last thing and then ask you to tell me what is likely to happen. If I do df and say temp EST and event, and I do something like this, df dot temperature is greater than or equal to 40, and df dot, let me grab another thing, humidity. Humidity is also greater than or equal to 30. If I run this, what will happen? But I hope you understand the condition, this condition. Do you understand this condition?
Yes, sir.
Yes.
Yes. So this one here, I can decide to use the normal and like. So if I run this, what do you think is going to happen? Won't it blow up? Abi will blow up, Anna.
Yes, it will.
Into we MCQs up. Nanke bisa. What is the response? Now I say but you should know that this is going to blow up. The reason is I'm trying to access multiple columns, but then I didn't put it here as a list like this. And what again? The truth value for the series is okay, that's fine. Anyways, that is fine. So I'm trying to assess something that doesn't really make sense. So sometimes, let me see. Sometimes it doesn't make sense. I'm just trying to do something to see if it's going to work fine. Otherwise, oh, okay, this is working fine. Or was it because of the end? Oh, okay. Sometimes some of them will not make sense. Other times it will. But of course, over here, I didn't know what I wanted to do. But the only thing I knew I was going to do at this point is to select the EST and then event column whenever the temperature was more than or equal to 40, and at the same time the humidity was greater than or equal to 30. I can also add another one, okay, to say that, and at the same time df.event, okay, event is the same as rain. All right, so this is how we can complexly extract certain columns or rows based on specific conditions. So you can see a lot of them here. Okay. I try to give as many conditions also here for your reference. And yeah, this is where we get to know the data. I wouldn't waste so much time on this one, but it is as simple as you calling maybe max. If I call temperature.max, it tries to give me the maximum value in the temperature column. If you do min, it tells you that. But do you think this one here makes sense to even worry ahead about the minimum and maximum? Anybody with an idea why it's necessary to look at the minimum and maximum?
Move.
Come again. Hello. Okay. So my battery is running out, but let me wait for the warning. Okay. Anybody with an idea why it's necessary to check for the minimum and maximum during data pre-processing?
Pasty.
Yeah.
So I think it's important to know the minimum and the maximum in order to know where your data starts and where it ends, to check for outliers and all those things. That's what I think.
Yeah, so I think that is perfectly fine, because I may want to use the minimum and maximum to check for outliers. Now imagine we had a date age column, and I checked for the minimum, and the minimum age is -18. Now this tries to tell me that there's a problem with my age column. I checked the maximum, and the maximum is about 700. Come on, this is not Methuselah. So there's a problem with my data. So the minimum and maximum can be very good indicators for checking outliers. Okay, if you want to check the mean, you can as well call the mean on it. We have a whole lot of them: the standard deviation, the correlation, the covariance. So I hope you understand what the mean is. You understand minimum, maximum. You know what mean is, right? Average.
Yes, sir.
So in this class, it is up to you. You see, this is more of application. You are different from the undergraduate people, such that the undergraduate student, you ask him to calculate for the standard deviation. He knows the formula. He'll be able to calculate it, but he doesn't understand what to use it for. This one here is application of those funny things we were calculating. So at this point, if you don't understand the meaning of some basic statistics and why we use them, I think it's about time you just ask ChatGPT. ChatGPT, why do we calculate for mean? What is it relevance? ChatGPT should be able to assist you in some of these things. Or you can do a very quick Google search, use Gemini and the likes. It should be able to get some understanding of it. Why do we calculate standard deviation? I don't know if you know. Right, for variation purposes. But of course, to say variation, it doesn't make sense. But this is what majority of us here know, that standard deviation is for variation. It's not just about variation, but wait, anybody who knows the meaning of standard deviation, the practicality of it, apart from saying variations? Anybody with an idea? Oh, Obianim. So should I continue? So what is the meaning of standard deviation?
Hello. So is it? Can we say is the measure of departure or degree of departure from the mean or from the average value?
So why do you want to know the degree of departure from the mean? Why do you want to know?
Yeah. So we are looking for the the core of any experiment is to get to the near true value, or value that's identical to what the true value is. So how far we deviate from that true value is what we are looking for when we look at standard deviation.
Well, it's not entirely true. We are not just interested in how far we deviate from the mean. Of course, that is true, but it's not entirely. That's not, to be honest, that's not the reason why you do standard deviation.
Okay.
Any other?
Pasty, I think the standard deviation also measures the risks.
Okay, I think this guy is a finance person. You have a background in finance?
Yeah, I do.
Oh, yeah, I think I understand why you are mentioning risk. Of course, a standard deviation measures risk. And any other?
Pasty.
Yes.
Talking about how it measures the spread in the data.
Okay, so if you know the spread in the data, so what?
We are trying to see if the data is consistent relative to the point.
Well, the spread in the data doesn't mean that the data is consistent. It may have some meaning related to consistency, but my point is that, okay, let's say right now, you were a teacher in some school, you work with some bank. Now the bank gave you some data. You decided to run some statistics on it. You ran the statistics and then you found the standard deviation, a very big number. But my question is, why did you calculate the standard deviation? What do you need it for? And someone is talking about risk, variability, like how far away the values are from the mean. Yeah, of course, that is true. But why? The point is this. You want to build a model, okay? And the model you want to build, you want to check the errors, and you want the errors to be as little as possible. Now, moving forward, we are going to give the standard deviation a different name. It's nothing, it's just the same standard deviation moving across different phases with different names. Our goal is to minimize or to get to a point where the standard deviation is very small. And so therefore, if I have two standard deviations, if I have a data where one standard deviation is 23 and another with standard deviation 20, now I'm saying that this one here is closer to the mean than this. And so therefore, the variability in this data here is lesser than this. So the smaller the standard deviation, the better. Let me give you a practical example. Let's say you have two classes, okay? A, and then we have B. Okay. Now let me say the first class has got 5 people. The first person who wrote the exam and the first person had 10. The second person had, let's say 12. And the last person also had, let's say 10. Okay, let me do 10, 10, 10, 10. So what is the average? The average is 10, of course, right? Okay, now let's say this one. The first person had, say 30. The second person had 0. Let me put 1 here and change this to 29. Let me change this to 28 and or maybe 27 and put 2 here. Okay. Now, what is the average for this one too?
The same thing.
The same thing. Okay, we have two classes. The first class is A, the second class is B. Now, I want to ask you, between the first class and the second class, which class performed better?
First class.
I would say E.
The first class. Okay, Obi say first class na performing better. When the average is 10 and then B to the average is 10. Okay, so Obi say first one na performing better. Any other person or any objection? Any objection? Okay. Now, what happens here is that The reason why the average here is 10 is because of this outlier, this guy, who had 27. And when we are making a conclusion, we say that on the average, everybody in the class scored 10. Where there is only one person, we know just one number the mean can be influenced easily. But look at this, every single one of them is scoring 10, 10, 10. That means this class here performed better than this. But you can't look at the face value over here to say that this one here is better than this one. You have to look for the standard deviation. Now let's look at something called maybe mean deviation. What did this guy here had? 10, right? So what is the mean? 10. So Abi, you know the formula for standard deviation, right? When you put the summation of each value, subtract the mean from it, and then square it. I hope that's it. When you are done, you pick the standard deviation of it, and that gives you the square root of it, and that gives you the standard deviation, right? Okay, so let's say I have 10. What is the average? 10, right? What did the person score? 10. So if I square this, what is the result? 0. What is this? This is 10. I'll subtract the mean from it and then square it. When I square it, what is the result? 0, right? What is this? 10. This is also 0. So if I put all of these things together in the standard deviation, what is the standard deviation for this? This is going to give you 0, isn't it?
Yes.
Good. So that you remember we said the smaller the standard deviation, the better. So this is saying that, well, the standard deviation for the class is 0. It means there was no variation between the actual scores of the student and the mean score. It means if the mean is 10, everybody had 10, 10, 10. Now let's apply the same thing to this. What is the mean? 10. So if I should subtract 10 from this and then square it, that is 17 squared. Anybody with an answer? What is 17 squared? The next person should also do
289.
So this is 289. Now this is a -6. -6 squared is
36.
36. And then this is minus 10. Oh, sorry, it is -8. Is it about 60 something, Diana?
64.
64. Yeah, and then this is 10. So this is supposed to be 9, right?
81.
81. Okay, so if we let's sum all of these values. And then make sure standard deviation.
434.
434. But you know these values here are inflated. So this guy here is called the variance. Now put a square root to this one and let's see.
20.8.
20.8. Now you see the standard deviation for the class B is way bigger than the standard deviation for this. It means that if the average is 10, look at the gap between 10 and the rest. Look at someone was scoring even below the average by 10. We have 2 people scoring below the average. This is by 9 and then this is by 8. And so therefore, there is variation within the data. It is too big. I say few numbers I say Oma Kata at the end. So I don't know how to explain it, but just about a few numbers scored very good results, and they are shielding the poor student to make it look like they all performed better. So the mean is saying that they all performed better. Then the standard deviation is trying to expose them that, hey, you are lying. The deviation, the spread is too big. It means just about 5 people performed better and the rest of you are hiding behind it. But this one is saying that, hey, there is no spread. The spread is 0. Let's even say the spread is 1. I mean, just one standard deviation. The spread is just very close. Okay. And that's the reason why we do standard deviation. So you may want to do the standard deviation to make sure that, oh, no, I want a very small standard deviation. If the standard deviation is big, it means there's one guy in the data set or a few of them that are shielding the wrong values. Do you understand?
Yes.
Okay. All right. I don't know if it makes sense to some of us here, but there's no statistics class. If it was statistics, I'll just take you down there into details for you to understand how the concept of even mean came about, standard deviation, how it came about, mean deviation, variance, how all of these funny stories came about. But anyways, there's no statistics class. Okay. Of course, we can also find the covariance and then the correlation. Okay. Anybody understand covariance?
Oh,
What about come again?
Please explain it.
What about correlation? So the covariance is looking at changes. Okay. But this time around, the change is between two variables of interest. We are looking at the two variables at the same time, how they change. All right. So we want to look at how two different variables change at the same time. Now, the correlation over here tries to tell us the relationship between two different variables. Such that if this one is changing, what is going to happen to this? If this one is increasing, what will happen to this? That is the correlation. Okay. Now, what we have over here is the correlation. But look at this. There is a perfect correlation between temperature and itself. It means when temperature is going up, this one is going up. This is also going up perfectly. But look at dew point and then temperature. It's saying that when dew point is going up, temperature is also going up, but it is not perfect. Now look at sea level and then temperature. This one is saying that there is an inverse relationship between sea level and then temperature. It means that when sea level is going up, temperature drop. Or when we are about temperature now sea level will be dropping. That is the meaning of this one. So the negative sign over here tells us an inverse relationship. But anyway, maybe someday if we meet for statistics, we can talk about some of these things in details. Now we have the last guy over here, which happens to be the describe. It tries to put all of the funny things we are doing together. So when you call data frame.describe, it gives you an overview of the data with respect to the number of items in here. In fact, if there is a missing value, this guy will expose it because it counts then missing values. Okay. So look at the wind speed. You see some numbers, some values are missing. So he's saying that we have only 28. The rest are missing. So this guy here tries to expose missing values. It helps you to understand if there are some missing values in your data. This one here gives you the mean across all of them, the standard deviation across all of them, and the minimum. Look at dew point has got -3. I don't know if the dew point can reach that level of negative. I don't know. But whoever will ask you to build a model, they'll have to explain to you what these columns are and the possible values they can take. Okay. All right. So we want to look at, we will close very soon. We want to look at how to handle, yes, come in.
Yeah, please, the previous slide.
Here.
It's looking like the columns are not up to the total. Can you explain the reasons why some of the columns are not there? Because
why some of the columns are missing?
Yes.
No, this one here, I think, you see, like I said, this is analysis I did some time ago. So this may be a different data point. Now, let me show that to you. I have, if I go to data, you see, I think what I gave you is the weather data. You see, I have a whole lot of weather data over here. And this is what I gave you, full weather data. And I have some small weather data. So I think that one was launched on the small, no, not this one. But honestly, I was using a different data set. But if I can try it over here for you to see, df.describe. And we should get all of them. Okay, we should get all of them. So the only ones that are not going to appear are going to be the non-numeric ones. But aside that, all of them should show up. So you see event. Event is not numeric data type. And so therefore, it wouldn't show up here because we can't get the standard deviation for a non-numeric column. Do you understand? Hello. Someone asked a question and disappeared.
First, I think we will get you. I don't know who asked, but I think we get you.
Okay. All right. So chances are that I was using
Hello,
a
Pasty.
different. Yes, come in.
I wanted to find out that when you call the df.describe, those the I don't know, the standard deviation mean 25%, 50%, something, it's already built in that when you call it, it will automatically gives you those results, or I don't understand it.
Yes, when you call describe, it will give you all of these things. Now, this guy here is the 25th percentile. Okay, so if you want to do it manually, that is fine. You can grab the 25th percentile, 50th percentile, and the 75th percentile. So immediately you call describe, it is going to give you all of this. Now, if the arrangement looks some way, you can transpose it. We can do .t, and it switches columns. You see, the temperature and things are now here, and the count, mean are now here. But if you like this view, you can as well do that. You can do df.describe and .t. That t is transpose. Okay. So we want to look at how to handle missing data. And then to handle missing data, first, you may want to check if there are some missing data in there. But of course, we know from this point that we have some missing data, right? Look at this. We know from this point that there is some missing data. But programmatically, this is how we check it. We can just say, is there any value which is missing in the data? Okay, so if you do this, it tries to tell you if that column has got a missing data. It will tell you that, hey, it is true, some records here are missing. So we can do df.isNow.any. Do we have any of them missing? So you can see that the EST doesn't have any missing data, but the wind speed has got some missing values. And then events also have got some missing values. Do you understand that? Okay. So you may want to even check this one before you go ahead to handle the columns. So if this one has got missing values, you have to handle this and handle this. You don't have to waste time on the rest. So you use df.isNow.any to check if some values are missing. So this is how we can handle missing values. We have several approaches. The first one here is trying to say that you should delete it. If we have a column with missing value, just delete it. But there is something more to it. So let's do this. Let me call result and say df.drop now. The drop now is like delete or drop, how do we call it? The row where you find some missing value. But look at what it takes. The axis over here is 0. The 0 represents the row. If you put axis 1, then you are talking about column. So you want to remove the entire column. So we usually want to use axis is equal to 0. Now the next thing I would want to include is the how. Now with the how, we can put the or. Now when we say, okay, I want you to drop any row. In fact, let me include something here. If I do df.head, if I do this, I'm saying that with this, what I'm trying to say is that go through this one. If you find any row with a missing number like this guy, okay, But the how is specifying that, okay, at this time around, not maybe one row, but if all of the rows, or let's say all of the values in that row happens to be missing. So this one is missing, this is missing, this is missing, this is missing, everything is missing. Then this guy here is going to work. It is going to drop that row totally. But if you use the how and say any, what is going to happen is that it will just scan through the row to say, do we have any value missing? If yes, it will drop the row like this. If I run it, it should drop this guy. It should drop this guy, okay? But that is what we are trying to make an argument that, look, if we say or, then we are dropping the row if this is empty, this is empty, this is empty, and this is empty. But look at this one. If we specify any, then all we are trying to say is that, look at the or. You see, we have all of our data sets in there. But when we did any, look at it is left with just 3 of them. The reason is that we said if any of the values is missing, drop it totally. So this, nothing, nothing, nothing. So it should maintain this. 1, there is something missing here, so drop 1. 2, there's something missing here, drop, 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 drop. It will keep dropping, and it will keep 0, 7, and then 8. So if you use how to be any, okay? But of course, it has a default value, okay? That you may want to check. The how is any. So if you just do df.drop now without passing anything to it, it is going to drop it when it finds even a single value missing in that row, okay? So if I should do this and then now run result, let me get the size. You see, after dropping this guy, you see, the data is left with this. In fact, let me check the how do we even get this? The shape. See, it's left with 7 rows and then 11 columns. But let me check for the actual data. df.shape. Look at 31 rows, 11 columns. Look at the amount of data we lost. That is the difference between this one and this. So you may want to be careful when you want to use this one. So you can see that drop row if any of the columns has missing value. So we try to make a conclusion that it's not the best solution. Our data is already finished. So you can't even go ahead to build your model. Now we have another one where instead of dropping, we don't drop it. We try to put some values over there. And this is one way of doing it. Now let's look at this. If I have df.head, see this. If I want to fill all of the missing values with 12, say df.fill now to 12. Let me call head. See, look at event. Let me take, there's a guy called sample. It's going to collect some at random. Okay, let me sample maybe 10. Okay, now, you see, so as we are moving on, new things are showing up so you can understand what sample does. Now, look at this one. We try to say that you should fill now. You should try and then fill any missing value with 12. Now, look at this one. This column here is supposed to be event, the fog, snow, rain. But look at, we are finding some numbers in there, which is wrong. We only want to replace these values with something similar to fog or something, but not numbers. So we're trying to call the fill now like this on the entire data frame is a bad idea. So you see, these are supposed to be categories. So we got it wrong here. Now, we try to use another approach to handle this. So this is how we did it. Instead of we filling it with, let's say, 12, we try to specify that, okay, for the column temperature, fill it with 12. with the colon wind speed, fill it with 1, and with the colon event, just put no event there. And you can see that I think this one is looking a bit better, right? As compared to this one, where it was putting 12 everywhere. So I think this looks better. Anamiba.
Yes, sir. It's nice.
So I think this one looks a bit better. But of course, there is even a better approach to handle this one, other than specifying what values you want to put here. Wouldn't it be interesting if the temperature, you decided to put the mean, the average value for the temperature here, so that you fill it with the temperature, other than putting any random number there. Okay. So we have this one, the forward fill. I think you've seen this in Power BI, so I wouldn't want to talk much. So the forward fill is more like, okay, this one here. Okay. But remember, what I'm printing here is the result. The result is the backward fill. Okay. So you remember this one, item number 3. So item number 3 was missing, and the backward fill was using backward rain. It pushed this one forward. And this item number 6 was no event. It pushed the cloudy up here. So you can see cloudy is pushed to item number 6 and this. If I use the forward fill, this one here was going to be snow. Okay, and this one here was going to be sunny. Any questions?
I have a question.
Okay.
Yeah, so is it possible to use a conditional format to determine how we should fill it? Let's say, for instance, if temperature is beyond 30, then you should fill it with maybe rain. If it is below 30, you should fill it with maybe sunny or snow or something.
We can do that. You want us to prove it here? You remember we did if statement?
Yes, sir.
We did if statement. So we can write if here. If df dot temperature is greater than or equal to, do we put 40 or something? Just anything, 30. Then what do we want to do? We want to say df dot fill now. And what do you want to put there?
So let's say
we don't want to. We are going to pick in fact, event, right?
Event, sir.
We are going to pick the event and then fill it with something. Let's say rain. And this should work fine. Let me see. What did the truth value for series is ambiguous. Empty something 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 dot any. I don't know why this one here is happening, but it should be able to work. Let me see. Probably because of some of these things. I don't know. Still, the truth value for the series is ambiguous. So does anybody have an idea why this is happening? In place, let's go to true. Now, what the in place does is, after, if I don't put in place here, when we are done with everything here, we have to return the results and then use it later on. If I put in place to be true, I'll say that, hey, modify the original data that we have in this one here. Okay, I don't know why this one here is not working, but this should be able to make sense. I'm coming. So let me grab this code here and then go to ChatGPT to see if I'm getting something wrong. So I'll ask it to correct this code. The error message is, so the reason why I have to take it to ChatGPT is, this is programming, and most often you don't have all of the stuff in your head. So you may want to reach out to existing resources over there, then you can use it to your advantage. Okay, so this guy is saying that df to numeric this error coerce and use bool if this, oh, okay. So I think this one here makes sense, right? So let me see if it makes a lot of sense. So it's saying that we were supposed to grab the rows, and then you know how to grab the rows, right? The rows is the location, the law, this one, this. Do you understand?
Yes, sir.
So he's saying that we should try and then grab the location before we do that. And then what is the location? The temperature is greater than or equal to this. And we are going to fill anything of that sort with rain. Well, it's making the whole thing complex here, of which I'm getting a bit confused anyways. So, senior, I think it's something we have to look to it, but I'll try and then figure it out.
We can continue and then maybe later.
Yeah, but what you need to understand is that this one here is possible. We can write like conditions like this to get the right thing.
All right, sir.
Okay. Yeah. So I think what we are failing here is a matter of logic. So maybe we can look into it and then fix it as we move forward. Okay, so we've seen the forward fill and then the backward fill, and there's this issue of duplicate. Please, in duplicate, you don't think, you just remove them. Because if you have this set of records saying that sales for today, so Ajwa bought something 100 cedis, and you accidentally recorded it twice. So today, how many sales did you make? According to this record, you made sales of 200. It is actually going to affect your output. So what you would want to do is to remove all duplicates if anything like that exists. Okay, so this is it. We first try to check if there is any duplicate in our data, and we can do that simply by doing df dot. If we have any duplicated value in there, do we have anything like that? It says that, hey, you don't have any duplicates in there. But if you have duplicates in there, you may want to drop all duplicates. So you can do df dot drop duplicates like that, and it will be able to remove all duplicates. And in fact, let me save it. In place is equal to true, so that it will affect the original record. So if I do df like this, I can now get my results. So guys, these are few data cleaning techniques, but like I said, this is not all. There is something you need to learn to master data cleaning, and you have to learn something we call regular expressions. That gives you absolute control over everything. If you know something about regular expressions, you can control everything on the screen. You can match symbols, patterns, characters, anything. So please, I would want you to take some time out and then look at how you can even improve on your data cleaning skills. But at least the few we have over here should get you going. Okay. I don't know if there is any question. Otherwise, the next thing we are going to be talking about is machine learning, how we can build our own regular machine learning models, and then even go ahead to look at. But before we build any machine learning model, we are going to clean the data, okay? So the data pre-processing is going to continue or follow us till we finish the class. Because any data we have, you have to check that everything is okay. Once it's okay, you split your data into training and then test data sets. Then you train your data set, then you check the accuracy with respect to predictions. Any questions up to this point? Any questions?
Yeah, Pasty, please.
Yes.
And this just a way for you to show me how to get the data, the very first step, because I saw your data was in the same folder. Mine was in a different folder. I tried retrieving it using the command line, but it's not working. So if you could show me an example of how to write the command when it's in a different folder.
Like this one. Okay, so let me try and then access some data here. Let's say I have a folder here called data, right?
Yes.
Okay, so let me get into my current working folder. Oh, which happens to be here, right? Okay. I want to create a new data frame and then call it pandas.read CSV. Data frame is equal to pandas.read some CSV file. Okay. Now, I have to specify the full part. It is advisable you drag your folder and then put it in the same directory. But just like you are saying that it is not here, this is what we are going to do. We are going to step out of the current folder called pandas. Okay. Okay. So if I come here, this is where we are. We are here. We have to step out of the folder called pandas to get here, to get to this place. So what I'll do is I'll get out of the current folder. So if I do $/, it means I've stepped out of this folder. I'm currently here. This is where I am now.
Okay.
So now that I'm here, I want to step out again to say that, hey, the folder, the file is not here. So let me step back.
Okay.
Now it is found in a folder called, because we are now here, it is found in a folder called data. So I'll call data. So I'm now here. Now I can now call, let's say I'm interested in full weather data. I can do full weather data dot CSV. And so therefore, if I should run df.head, I should get this guy.
Okay.
Otherwise, if I want date underscore fruit underscore data set, you see that it's giving me something different.
Okay. All right.
Okay. Yeah.
Okay.
So yes,